Hello, everyone. Thank you so much for joining another GMAT free prep hour from Manhattan Prep. My name is Tiffany Berkebile. I'm an instructor with Manhattan Prep, and I am joining from Ann Arbor, Michigan. In chat, one of my favorite parts of these sessions is to see where everyone else is joining from. As you jump into the session here, please let me know where are you signing in from? The other question that I always like to uncover from attendees is how long you have been studying for. That's another really great question to understand for me as the instructor here. I will say though that all ability levels are welcome this evening and at all of our GMAT free prep hours. We try to make these as open as possible and try to make sure that there is something for everyone, whether you are just starting your prep or you've been doing this for quite a while. Awesome. Thank you, Jenna. Montreal in a little over a month. Nice. Excellent to hear. Hi, everyone who's joining. I love to teach these GMAT free prep hours because they allow us to dig a little bit deeper into some topics that I don't always get to dig deeply into in courses. Plus, it's really nice to see from a lot of students who don't necessarily join the paid courses as well. All right, as you join, please let me know where you're joining from, how long you've been studying. It's always exciting for me to see, of course, and helpful. Excellent. Well, tonight we've got some interesting things planned. First, I always like to make mention of the free options that we offer for GMAT prep. As you go forward, you likely are asking yourself what your study plan is, unless you already have one, in which case there are many, many different ways that you can study. Of course, we offer paid courses and paid tutoring. However, we offer numerous free options as well. Several of them are listed here. You can go to this website to learn more about our free options. We do offer the ability to attend the first class session of each GMAT course live. That's a really helpful class session to attend as well. It's not a marketing session by any means. There is content. It teaches data sufficiency process as well as sentence correction process. Attending that is really helpful, especially if those two topics are something that you know that you're struggling with or think that you might struggle with in the future. I am particularly process focused. I know that a lot of instructors are, but I feel like I really, really lean heavily into process. When I say process, when you think about your studying, there should be things that you are doing to set yourself up for success on any given problem. When you think about quant, there should be certain ways that you are approaching quant problems every single time. Now, every problem is a little bit different. So of course you're adapting your specific strategy and solution method to the problem in front of you. But using some repeatable process from question to question means that you always know what to do next. So even when nerves hit, even when you're feeling a little bit uncertain, you're prepared to move forward and you have a plan to move forward. The process that we use for quant in particular is called understand, plan, solve. I'll talk just a little bit about it tonight. We do offer some other free sessions that are available on YouTube that cover this topic more fully though. So if that's something that you are not aware of, I would strongly recommend that you dig into it a little further. Sentence correction also has its own process. We also have other sessions on YouTube available for that topic. All right, moving ahead here, tonight we are going to be talking about geometry a little bit further. These are several things that I want us to make sure that we talk about tonight. I will make sure that we recap them at the end a little bit as well. What we're going to be doing is several practice questions to illustrate these particular points and to show you how geometry appears on the GMAT. One thing that I try to emphasize with all of my students, including students for free prep hours, paid courses, tutoring students, is the fact that when you recognize what you're being tested on, that helps you to understand patterns and see patterns that you might not otherwise on the GMAT. Doing that gives you a significant advantage because you have a sense for the types of things that might trip you up. You have a good sense of how you can approach the problem, and it just arms you for greater success, essentially. Now, geometry is sometimes easier to recognize and sometimes more difficult to recognize. So we'll explore a little bit how this appears typically on the GMAT in particular. All right. What we have coming up next here is our first practice problem of the evening. I am going to give you 2 minutes to attempt this particular problem. So take a deep breath. And here is your problem. Your time starts right now. Hey, that is 2 minutes. It goes by quickly. As you continue your prep, another great idea for you to do is to take stock of how you feel after completing practice questions, right? Notice, is this something that was difficult for you? Was it something that was easy for you? And notice too, how much of that time did you spend on certain activities? I'm going to walk you through how much time approximately you can spend on all these different activities here. But ideally, when I talk about process on particular questions, what I'm meaning is that you should always know what to do next. And you should always have a plan on how to spend your time and what you're going to be doing with your time. Really, at the end of the day, all that you have on the GMAT is your time. That is your most valuable resource. So you have to use it wisely. That's your primary goal. All right, is quadrilateral ABCD a rectangle? So I always start by reading the question and phrasing it in my own words. ABCD a rectangle. This seems like a pretty simple question at first glance, but there is a little bit of complexity here, and we'll talk about what that is. Now, looking at this, I'm already aware that a rectangle, I mean, of course, we all probably know what a rectangle is, right? Just this approximate shape. But I know that in looking at the GMAT and GMAT questions on the GMAT, there are other shapes that could certainly be confused with a rectangle. So the first thing I'm thinking is that this is a very simple question, and that ideally I want to avoid making any assumptions that would lead me to think, oh yes, definitely this is a rectangle. Not a lot of other information at our disposal here to work with. So this was essentially the understand phase of this particular problem. In looking at these statements, because this is a data sufficiency problem as well, We also need to do a little bit of understanding for each of these also. In chat, let me know, did you start with statement 1 or statement 2? Either one is absolutely fine, by the way. You do not have to always start with statement 1. In fact, it's often better to start with statement 2 just because sometimes the test writers hide some things in statement 2. They know that people are going to statement 1 first. All right, taking a look at these. Line segments AC and BD bisect one another. It's always a great idea to draw a picture. I don't want to assume that this shape is a rectangle immediately. So I'll draw a couple of different shapes here just to see if this works out. So I know it's a quadrilateral. I've got A, B, C, D. This is typically how these are labeled, going around in a circle just like this. The lines bisect one another just like that. I know that this shape is a parallelogram. I don't necessarily know if it's going to be a rectangle. Based on that information, then statement 1 is going to be not sufficient. And knowing that too, I can start to fill out my little answer grid here, right? If you are not familiar with this answer grid, it's a huge time saver. I would definitely recommend that you look into it further. What you're doing here is representing the answer choices so that you can easily eliminate them. All right, so I know that statement 1 is not sufficient. Looking at statement 2 then, angle ABC is a right angle. Well, I know again that I'm working with a quadrilateral, A, B, C, D. This is a rectangle version. So I've got angle ABC is a right angle here. So again, this tells me something similar, right? But I still can't make any assumptions. This could still be a square, for example, and this would absolutely still be true, not sufficient. Just taking a look at chat here. Yeah, Jaideep, very good question. Absolutely. It's a great idea to memorize these rules, especially for geometry. Geometry tends to be a little bit heavier in rules than some of the other areas on some of the other content areas tested on the GMAT. So memorizing some of these certainly is a really positive move. All right, taking a look at statements 1 and 2, then I know that my answer is not going to be A, B, or D, so it's going to be either C or E at this point. Taking a look at statements 1 and 2, according to statement 1, quadrilateral ABCD is a parallelogram. And if a parallelogram has one right angle, then all of its angles are right angles. So this is another of those rules, Jaideep, that's very good to remember, right? In a parallelogram, opposite angles are equal and adjacent angles add up to 180 degrees. Therefore, this parallelogram in particular is going to be a rectangle for sure. You know this based on the rules of geometry. So in this case, we use a couple of important skills that you're going to want to remember. First skill being that you need to draw out the shapes in order to understand what you're looking at. Second skill being that you really do need to understand some of the basic rules of geometry in order to be successful. So if these rules are something that you are struggling with at this point, strongly recommend that you go back to, if you have books or other resources, then you do some exploring within those resources. You also can find a lot of free information online, of course. All right, let's take a look at our next practice problem here. Got another one coming up for you. All right, you're gonna get 2 minutes on this one as well. I always recommend taking a deep breath between problems. I find that it helps to clear your mental space and make you more successful going forward. All right, so take a deep breath. Do it all together. Here is your next problem. And your time starts right now. All right, that is 2 minutes. Again, pause for just a moment and think about how this 2 minutes felt. Think about how you used your 2 minutes. Do you feel like you used it wisely? Do you feel like there is something that you would have done differently looking back? All right, we're going to do something similar to what we did last time, right? Take a look at this, and the understand phase is up front here, where we take a moment and think about the information. I talked earlier about understand, plan, solve. So just really quickly to reiterate and expand on that a little bit more, it's also something we call UPS. This is something that you're doing while you attempt the problem. So understand is just understanding the information. And this is about 30 seconds up front, maybe a little bit less, maybe a little bit more. But essentially you truly are just, you may be writing some things down, but it's just to gain an understanding of what you see in front of you. Planning is a phase where essentially you're making your plan, right? You're using the information you gathered here and understand, and you are trying to simply make a good plan of attack to move forward. Solve is then when you use the phase where you use the information from the understand and plan phases to actually attempt to solve the problem, which means that you're spending anywhere from 15 seconds to probably a maximum of a minute just understanding and planning. You're giving yourself that time so that you can create a good plan and understand the information. One thing that many of my students struggle with, that I have seen at least, is that they'll jump into a problem without having this full understanding or without having a good plan. And at that point, solving becomes very difficult. It's sort of a process of guess and check instead of a nice, clean, organized process to move forward. So taking a look at this, let's do some understanding together. All right, I always like to start with the question. So we did that last time, but basically all of the information provided was the question, right? Here we actually have a nice question word pointed out. What is the area of equilateral triangle ABC? So when thinking about this, I know that I'm looking for area, of course, and I also know that I'm given an equilateral triangle. This is why I love to read the question first, because it tells me things about the problem that I might otherwise miss if I read it straight through. So I've got a really good sense of what's going on here. I can even label it like it is drawn in the actual figure. That's going to be A. Always a good idea to redraw things as well on your scratch work. I drew it a little bit differently for myself than, of course, how it's represented here. And I did that because I really wanted to see this as a triangle with C this way. This makes me feel a little bit better. You can draw it however you would like. All right, if points A and B are on the y-axis in the figure to the right, what is the area? Great, so I know that these are points on the y-axis. I don't know where they fall. There does appear to be a little bit of space here, right, from the origin to point A, but I don't know how much space. I do know that all of these sides are equal, which is extremely helpful to me. The first thing that I'm going to think about that is that I'm looking for the area, and I know that in an equilateral triangle, or any triangle really, right, the area equals 1/2 base times height. Since this is equilateral, that means that if I have information about the height, for example, then I know that this is a 30, 60, 90 triangle though, which means that there's a relationship that's shared between the sides. Knowing this pattern is just making me a little bit more aware of any patterns that I might see within the statements themselves. So I'm recognizing, doing a bit of predicting in advance to make sure that I'm conscious of that. When you're doing predicting like that, it really should not take very long. It's not something that you're spending a lot of time on. It's just something that you are doing very briefly to prime yourself for what may be to come. All right, looking at statement 1, the coordinates of point B are 0, 5, radical 3. Now, in looking at this, I'm going to draw it the way that they drew it again. We drew it because this is Manhattan Prep. in looking at this, I'm making this space a little bit more pronounced between the origin and A, just to remind myself that there is a space there. If I know that this is 0, 5, radical 3, then I do know how far B is from the origin, but I still can't tell you this length, right? I don't have any sense of how big the base is because I know that there's a little bit of a gap here. And knowing that, and then thinking about my area formula, 1/2 base times height, I'm wondering, how can I get any of this information? I either need the height here, or I need some sense of this distance in order to be able to get the area formula. In statement 1, I simply cannot do that. This one is going to be not sufficient. I'm going to make my answer grid here, A, D, B, C, E, and it's not going to be A or D. Both options A and D require statement 1 to be sufficient on its own. Yeah, hi, I'm getting a chat here. I think this is statement 2 because you know the midpoint of line AB, so you can figure out the distance. Yeah, let's take a look at statement 2 here. The coordinates of point C are 6, 3, radical 3. And this is where you want to be cautious in a lot of types of problems, right? Data sufficiency problems that relate to geometry, that relate to stats, really that relate to many different things. When you see two statements that look substantially similar to one another, be cautious with that. These two do look very similar, right? Here I have point B, here I have another point, point C. However, in looking at the figure that is drawn here, statement 2 gives me some information that statement 1 really did not. I saw it in chat, but can anyone else illuminate as well a little more clearly? What does statement 2 give you that statement 1 did not? Yeah, thank you. It gives you the height. It very clearly gives you something that you can actually work with here. Statement 1 was just a little bit too ambiguous. Here we do know this is 6, 3, radical 3, which means my height here, right, has to be 6. I still don't know this distance, but ultimately it doesn't matter all that much because this is an equilateral triangle. And I still remember that from the information that was given because I drew it out here. Knowing this then, I know that if this is 6 and there's a relationship between these sides, then I should actually be able to figure out the remainder of the information I need for the A equals 1/2 BH formula. I say this because in looking at a 30, 60, 90 degree triangle, just as a reminder, the side lengths are going to be 1, radical 3, 2, and these correspond to the different angle measures, right? So this would be the 60 degree angle, this would be 30, and of course this would be 90. At this point, however, I am going to stop because I don't really care to do any of this work at this point. This is a data sufficiency problem. I know that I can get this information. I know that I can solve it, but ultimately there's really no point because I don't have to come up with a specific answer. I just need to know that it is possible. Statement 2 is in fact sufficient, which is really interesting, right? Because as I was mentioning earlier, sometimes things are hidden in statement 2 because of it being statement 2 and following statement 1. The GMAT test writers know that most people are going to start with statement 1. When you do that, your perceptions are colored by what you read in statement 1. You're more likely to look at statement 2 and think, oh, that's not sufficient because it's similar to what you already saw. All right. We are going to move on to another practice problem. We got a couple more lined up here. Before I do, in chat, just really quickly, what's one takeaway that you have so far? I like to have people write this in chat because it's a really, really good idea to get in the habit of writing down your takeaways. It's a particularly good idea to create an error log where you are tracking problems that you attempt and things that you learn from those problems. Even if you're not tracking it in an error log though, and I'm asking you to write it in chat as I'm doing now, it's still valuable, right? Because you take a moment, you write it down, that really forces you to think about what you are seeing. Seeing this question in chat, if this was an isosceles triangle, would it still be statement 2? If this were an isosceles triangle, would it still be statement 2? I haven't really thought about that, so let me think about it for just a moment. Not sure what you mean by the midpoint is still 3 root 3. Drawing an isosceles triangle here. Really the reason that you know that this works is because you know the angle measures. So you really do need it to be an equilateral triangle in this case, because you know that this is a 30, 60, 90 degree triangle right here. If this were an isosceles triangle, then you would know that this was 90 degrees, but I would have no way of knowing what this angle measure was or this angle measure. This has to do with, you don't know that the midpoint of, you know that the midpoint of A and B is 3 radical 3, but you still don't know how far away A and B are from 3 radical 3, because A is not on the origin. The important thing to note here is that you know the height of the triangle. So I've redrawn it here for that specific reason. You have this piece of information, and because it's an equilateral triangle, you also know, or we also know, that this angle measure is going to be 60, right? This angle measure is going to be 30 because it's 60 bisected in 2. And this angle measure is going to be 90 degrees because I've drawn essentially the height, right? I've gone straight over from the y-axis here. Because I know this information, I know that I can get this information, I can get this information, and at that point, I can get area equals 1/2 base times height, because I'll have 1/2 times the base, and then I'll have the height as well. This works because it's an equilateral triangle. All right. These are important takeaways. When you're looking at geometry, it is simply not enough to memorize rules. You have to know how to apply those rules, right? But you have to memorize them first in order to have that solid baseline on which you can grow and build. Once you have that, then you can start to get more detailed about looking at specific practice problems and ensuring that you can actually apply that information successfully. All right. Let's take a look at another problem. I'm going to give you 3 minutes on this next one. Actually, I'm going to give you 2.5 minutes on this next one. You can take up to 3 minutes when you're looking at quant problems in particular. You don't ever really want to take more than 3 minutes unless you truly are just wrapping up final touches on a problem. At that point, really, it's just a law of diminishing returns, right? A lot of people struggle to let go of problems. When you're looking at your results later, though, and you see spending 4 minutes or 5 minutes on a given problem, which is easy to do, trust me, it's very easy to do, then really what's happening is that you're taking time away from solving other problems potentially that you can solve. So 3 minutes is a great point to learn to recognize, make sure that you're doing some timing drills so that you're recognizing how long 3 minutes feels for yourself, and that you are practicing letting go of problems at that approximate 3-minute mark if you reach that point. Okay, let's do another problem. You'll get 2.5 minutes on this one. Take a deep breath, let it go. Here is your problem. Your time starts right now. Okay, that is 2.5 minutes. Excellent. Think about how that one went for yourself. Think about whether you needed more time, less time. Either way, it's totally fine. All right. Taking a look at this problem, you have a drawing here. Not a lot of information given in the question stem, not a lot of information in the statements either. So this one's going to be potentially more information in this diagram that you see. When you see a diagram like this, you really want to make sure that you do draw that out again for yourself so that you can label it appropriately and so that you can better understand the information that it does provide. All right, because I've been talking about it so much, I think we will start with statement 2 in this case, just to give ourselves a slightly different starting point than normal. What is the value of X? Here, I know that I am looking for one specific value of X. I need to be able to find that value. This is a value question. In order to successfully answer this question, I have to be able to come up with one specific value. All right, statement 2, Y equals 70. Looking at this particular drawing, it does appear that all of these lines are parallel, but that is a perilous assumption on the GMAT. When you see any kind of a drawing on the GMAT, including parallel lines, including any kind of a shape, you cannot assume anything about that drawing that you are not told. So in this case, I do not know for certain that these lines are parallel, which means I cannot assume that they are parallel, which means I know very little about this actual drawing. I know that if Y is 70, then this is going to be 110, this particular angle, because this does bisect a line. You can safely assume that these are straight lines. That's about all that you can assume here. That's all I know though, right? I can't take this any further for statement 2 in particular. This one's not going to be sufficient. This time I'm going to change my answer grid just a little bit. So it's B, D, A, C, E instead of A, D because I've started with statement 2. Statement 2 is not sufficient, so I know it's going to be A, C, or E. It's always good to have this checkpoint with yourself. You know, if you have already spent a lot of time on a problem and you've gotten it down to maybe 2 or just 3 answer choices, that's a great point to take a bail, right? If you know that the next statement is very complicated, for example, or you know that you're already behind on time, it could be a potential opportunity to just simply guess and move on to the next problem. You want to build in these touch points for yourself so that you can recognize them as you go. All right, statement 1 gives me some different information. Line 1 is parallel to line 2. So I am going to redraw this for myself. X, line 1, line 2. So those I know are parallel. I still don't know anything about line 3 and line 4. So I'm going to put little question marks next to them, noting to myself, hey, you don't actually know anything about these. That means then that since line 1 and line 2 are parallel, I do know that, for example, this would be the same angle as X. However, because line 3 and line 4, I don't know if those are parallel, I can't make any additional assumptions here. I don't know anything else about what's happening. Additionally, even more clearly in looking at this statement right off the bat, I don't have any numbers, right? I'm looking for a specific value of X and there are just simply no numbers. Not sufficient. Now I'm down to C and E, and at this point, again, if there's something that you don't understand about a problem, you've taken too long, awesome opportunity to guess. You've got a 50-50 shot of getting it right at this point if you've made it here. All right. Taking a look at both statements combined now, I'm allowed to do that because I've gotten through each of them independently. They still are actually not sufficient together. The final answer on this problem is going to be E. Because line 1 is parallel to line 2, we know the relationship of these 4 angles that I've pointed out for line 1 and line 2. However, in inserting Y here, we still don't know anything about lines 3 and 4. So I cannot make this particular connection, which means that even though I know that this is going to be 70 instead of just Y, and I know that this will be 110, I can't say that this also is going to be 110. This is a super easy assumption to make. This is a slightly more difficult problem than some of the other problems that we just saw. Most of that is because of the assumption that you're going to make in looking at this, that lines 3 and 4 are parallel. Yeah, I'm seeing in chat, wow, I thought this was C. It looks like C, right? This looks at first glance like it's going to be a C answer. That is kind of a classic C trap, honestly. If you look at a problem and think, wow, this really seems like it's probably C, question your assumptions. It should not be that easy, right, at first glance to know that the answer is C. And when you do have that occur for yourself, be very suspicious. Excellent. Any questions about this one before we move on? We've got one final problem to talk through. We know that they're flat. Yeah, so the question in chat here is, I know that lines 3 and 4 are in fact lines. And I know that the line 4 angle is 110 and 70. But in order to know the angle measures, they also have to be parallel, and I simply don't know that. So in thinking about lines 3 and 4, they could really look like this, for example. In the drawing, they don't, right? But if you don't know that something is parallel, it's best to kind of draw it in a way that is a little bit different. Like line 1 and 2, I know that these are parallel. So if I draw it like this to make this difference more pronounced, so that I'm like, yeah, I actually don't know anything about these, it becomes a little bit clearer, right? Like this is 70, this is 110. If line 3 and lines 3 and 4 are not parallel though, then I don't know anything about these angles. Does that make sense, Bradley? You can see it a lot more clearly, and obviously these are like opposite at this point, these angle measures from what they really should be. So these aren't true angle measures. I haven't drawn them correctly, but just knowing that these lines might not be parallel, I can't make any assumptions about what these angles are going to be up here. Now, if they told me that line 3 was parallel to line 4, then this problem would be C. The answer would be C. To make this feel a little bit more compelling, I'll draw this line like this. This is 70 degrees and this is 110, and this makes a little bit more sense just visually. Still don't know anything about line 3 though. No idea. All right, any other questions? We'll pause here. The other thing that you sometimes see in geometry is that, not in this particular problem, but I'll use this drawing as an illustration. You will sometimes see problems that ask you questions about angle measures. And you can get the information, but you have to recognize that this actually forms a shape in the middle. Again, this doesn't apply to this particular problem, but you do need to be on the lookout for the fact that lines can sometimes appear in geometry problems. And it's not really about the lines. It's more about noticing that there's some internal shape that's being created. And once you recognize that, then you can make headway and solve the problem successfully. Do you assume in problem solving that lines 3 and lines 4 are parallel? No. In any geometry problem, if they do not tell you that it is true for any given, honestly, not just geometry, for any given drawing that you have, even if it looks like something is true, you need to be told that that is true in some way. They can do it by indicating that on the actual drawing. They can like indicate that these are parallel somehow. They can indicate it in the statement, the question stem that you're given. But it has to be given to you in some way. You can't look at a drawing and think, wow, those look parallel, so they must be. It's not necessarily true. That's any drawing on the GMAT, data sufficiency, problem solving. Doesn't matter what you're looking at. I feel like this one's a crowd favorite or a crowd unfavorite, maybe least favorite here. We've got one more problem to do before we all head out. So let's take a look at this one. I'm going to give you 2.5 minutes on this one as well. All right, take one final deep breath for me or with me. Okay. Here is your problem and your time starts right now. All right, that was 2.5 minutes. Apologies, you didn't see the answer choices right away. I made sure they got up here though. All right. This one is a slightly more difficult problem than some of the previous ones as well, mostly because number one, it's a word problem, right? Word problems tend to be something that people struggle with just a little bit more because there's more organization that's required. Doesn't necessarily mean that they're always more difficult though. It just takes a little bit more to get organized and to think logically through the information. Again, I always start with the actual question that I'm given. It gives me context and knowing what to expect. What is the width of the cement deck in feet? Okay, so I know that I'm looking for a width. I know that that's what the answer choices represent. They're all multiples of 5, which is pretty interesting in feet. So I'm going to be getting some additional information, I'm assuming. And that information is probably going to contain some other lengths in feet as well. A rectangular in-ground swimming pool, again, draw it out, right? Draw. Measuring 20 feet by 40 feet. Has a cement deck installed that is the same width around all sides of the pool. So taking a look at this. Cool, I've got like a cement deck here. It's the same width. So this is X, this would be X. I'm actually going to call it W instead of X for width. And that's really what I'm looking for. And here I've got the same thing, right? This going this direction. The area of the pool and the cement deck is 2,400 square feet. So I have a couple of options at this point in terms of how to proceed. The first way that I could start to solve this is algebraically, right? I know that the total area is 2,400 square feet. So I could set up something that's like, okay, well, this times this equals, well, didn't extend it far enough, times this entire side is 2,400. I'm gonna have a lot of W's involved in that though, right? It's like 20 plus 2W times 40 plus 2W equals 2,400. At this point, I could really solve this. I could set all this up, I could continue to multiply this out, and eventually I would be able to get to a specific value for W. If this is the way that you did it, it's not necessarily wrong that you did it this way. That's absolutely fine. However, what I would say about doing a lot of algebra on the GMAT is that you tend not to be rewarded for that behavior. And I say that because it can be time consuming, it can be emotionally draining, it can be mentally draining, and it can be prone to errors, right? Conducting any step of this and making a minor mistake along the way can sometimes result in you choosing an incorrect answer. Not because you did the setup wrong, right? Not because you had a bad plan, simply because you made some mistake in calculation and the GMAT test writers saw that coming. So the other method, I don't know if anybody noticed this, probably some people did. The other method that you could use to solve this is working backwards. And working backwards, man, it is one of my favorite things to do because you use the information that you have at your disposal, right? It becomes so much easier. In order to work backwards, I'm going to work with the answer choices that I have and use that information to actually guide my approach. All right, I still know this information. I'm going to redraw it here. I've got 20, I've got 40. When you work backwards, you want to start with either B or D typically, and I'll show you why in a moment. So I'm going to start with D in this case. Now I know that these represent width of the cement deck, so I'm going to plug this in where I had W previously. So this will be 20 here, 20 here. I got a 20 going on here, and I got a 20 going on here. So now this side is going to be 20 plus 20 plus 20. So this is 60. And this side is going to be 20 plus 40 plus 20. So I've got 80 over here. When I multiply those together, I get 3,600. Ooh, not a match for the information here. And in fact, it's too large, right? Because of that, I also know that E is not the correct answer, which means that I'm working with only 3 answer choices remaining instead of 4 answer choices remaining. That is the benefit of starting with B and D. It tells you about the rest of the information because these answer choices are always organized in either ascending or descending order. So you can see patterns more easily. All right, let's take a look at B and see what that gives us. Again, I'm going to draw this out, and I'm making a lot fewer calculation mistakes than I might otherwise. This drawing is not beautiful. It is not to scale. However, that's absolutely fine. You just need to make sure that you get it on paper, right? All right, I've got 10. So this whole side up here is going to be 40. So far, so good. This side is 40 plus 10 plus 10. So this whole side is going to be 60. And there's my total of 2,400. So I know the answer is B. If the answer was not B and this was still too large, then I would know that the answer was A. If the answer was not B, but B was too small, then I would know that the answer is C, and I wouldn't need to do another check necessarily, right? It wouldn't be necessary to do to draw this out one more time. I could actually just know the answer based on that. And I would trust that too, if it were me on the official exam. All right, any questions about this one? This one requires you not only to have an understanding of the geometric principles, because that's relatively straightforward in this problem. Really, in looking at a problem like this, it's 4,800. Thank you. Ooh, it's been a long day. I always tell my students too. Thinking and talking at the same time are hazardous occupations. Absolutely. 60 times 800 is 4,800, not 3,600. Still too large. Thank you for pointing that out, though. All right, any other questions about this one? I'm not sure if I understand that question. Is B half of 4,800 because B is half of D? D would be a good answer choice here to include, because some people may forget, like especially if they're doing the algebra, they may forget to include 2W here, for example. So having a trap answer like D, which is double B, is super common for a question that's like this one. So if I wrote 20 plus W times 40 plus W, it could potentially lead me down that path where W isn't as much as it should be, right? It's half of what it should be. You could make this same miscalculation in drawing it out as well. Like I wrote out all my W's here just to be sure that I didn't miss this fact that W is on this left side and on the right side of 20. And it's on the top and on the bottom of 40, right? The width goes all the way around. It's a good question. All right. We've got just a couple more minutes here. Just a reminder, drawing pictures is something that we have talked about for all of these problems. Write out any known formulas. When we were looking at the equilateral triangle problem, I wrote out physically A equals 1/2 B times H. Now you don't absolutely have to do this, but I find that it's extremely helpful because when you write out the equations that you do know, you start to see patterns in those equations that you might miss otherwise, right? Like, oh, well, I only need to know 1/2 B times H. So maybe I don't need to know base and height separately, for example. What if I had them all in one piece of information in a statement? Writing this down also just gives you something to put down on paper in a concrete way to make you feel like you're making some progress. And sometimes that is half the battle, I will tell you. Infer, but not too far. This is what we were referring to when we saw that problem with the parallel lines. You cannot infer too far. You cannot see lines 3 and 4 in that problem, for example, and think, oh, well, they look parallel, so they must be. Absolutely not. You can make inferences based on information that you know to be true. When you saw the equilateral triangle and they told you it was equilateral, then you can infer safely that using the height line, this must be a 30, 60, 90 triangle. Super safe inference, right? It's just using information that you know to be true to get more information that you know to be true. You can't make assumptions though. Don't head into assumption territory. Finally, pay attention to the answer choices. So in this last problem that we looked at, as someone noted in chat, B is half of D. Why is that the case? If you're paying attention to answer choices in quant, they often will be sort of a guide for what you can expect. Now, data sufficiency, the answer choices stay the same, so that's not necessarily true, right? But for problem solving, I love to give those answer choices a nice look down before I jump into solving the problem, because sometimes I can see some patterns there that mean that I do have to do a whole lot less work than I might have to do otherwise. All right, before we leave, does anyone have any other questions about geometry or about GMAT prep in general? All right, I am not seeing any other questions, but I hope that all of you have a wonderful time preparing for the GMAT. Oh, I do see one question here. I've been studying for a month and my baseline GMAT score hasn't improved. You know, sometimes it takes a little while for your score to improve. You'll notice that you spend some time plateauing on a given score, and then sometimes it'll jump up unexpectedly. What I would pay attention to, though, and taking a look at your practice exams is your timing looking good, right? So are you spending a lot of time on some problems and not a lot of time on others? Are you running out of time at the end of a section? Or do you have too much time left over at the end of a section? Paying attention to those timing trends will often reveal some bad habits, essentially, maybe that you have for yourself, and some things that you can focus on. Any suggestions on CR? Yeah, we can definitely have a CR review in the future, but I would say know your process for critical reasoning. The temptation for critical reasoning is just to jump into reading the actual argument and then jumping into the answer choices. What I notice is that people don't sometimes stop to understand the argument fully and restate it in their own words. That's a super helpful step to take. And then the other thing that I notice frequently happening with CR is that it's easy to get into this sort of mental spiral where you are reading answer choices over and over and over again. You should eliminate them as you go. If you eliminate an answer choice, it is dead to you. You do not return to it. You do not read it again. The only way that you can really do that successfully, though, is if you have restated the argument in your own words and you understand it very clearly. When is it okay to divide by 2? To simplify for the last problem, $20 plus X times 10 plus X equals 1,200. Yeah, let's take a look at this really quickly. I'll share a whiteboard here. Oh, actually, here I can share my presentation again. Okay. All right, so it sounds like you set up the algebra for this. 20 plus 2W, you called it X, times 40 plus 2W, again, you called it X, equals 2,400, is this correct? And then you divided the whole thing by 2. Okay. You should be able to do this, honestly. It looks like you input this correctly into chat. I would check the rest of your work to see if something else happened along the line. Maybe some other calculation step. D works for that. Yeah, I see what you're saying. Yep. Thank you in chat here. Absolutely, you're missing the squared. You absolutely, I just saw this note in chat as well. You can absolutely see the recordings. They're available on YouTube. What's a general rule? Clearly I was just stumped by this one. No, I'm not stumped by it, just drawing it out here. A general rule, I think, is to ideally, before you start pulling things out, start to do some of this work, right? So like 20 times 40 I see the issue now. Plus 20 times 2w plus 40 times 2w plus 2w squared equals 2400. Once you get it into this place, what's going to happen here is that you can start pulling things out more easily. So probably just start to distribute like this, and then start pulling out factors. Yeah, you're absolutely welcome. All right. Thank you all for joining tonight. It has been wonderful. We'll have more free sessions coming up, so definitely check the schedule. Otherwise, please have happy studies moving forward, and best of luck to all of you on the GMAT. Have a nice evening.